Okay, so we've been talking a lot about straight lines in Algebra 2, and we're going to continue to talk about straight lines right now. What we want to do is talk about how we find the equation of a line, which we have some experience doing, so we're just kind of emphasizing how to do that. Today's goal with this video is to write the equation of a line. Oops, and I didn't leave myself enough room here. Write the equation of a line given 2 points on the line. Okay, so in order to write the equation of a line, you need to know two things about the line. You need to know its slope, which is something that we've already talked about. And you have to have at least 1 point on the line. If you have more than 1 point on the line, that is completely fine. There's nothing wrong with that, but you have to have at least one. There's actually two ways to come up with the equation of a line. You can use slope-intercept form, and we've talked a lot about that form already because that form helps us graph, but it also can help us come up with an equation. And you guys should remember that that is y equals mx plus b. We know that m is the slope, and I'll just make a little note here. And the y-intercept is that b value. So they're just placeholders. There's another form or formula that you may remember from Algebra 1. It is point-slope form, and that equation is y minus y sub 1. Just a little subscript there, no big deal. We'll talk about what that means. Equals m, and then we need some parentheses, and then we put in x minus x sub 1. M still means the same thing. M is still the slope. However, the x1 and the y1, those are the coordinates of a point that is on the line that you're trying to find. So nothing will ever go in or be substituted into y or x, but you'll always have to substitute the coordinates in for y1 and x1. All right, so I'm going to lead you through an example. I'm going to show you how to do the same example in two different ways. So I want to know the equation of a line that travels through the points 1, negative 3 and 3, negative 5. So this actually is exactly fitting our goal, finding the equation of a line through 2 points. Now, I had just said that you need to know the slope of the line before you can come up with its equation. This doesn't outright tell me the slope, but these 2 points, I can use them to help find the slope, and that's actually what I'm going to do first. So when I go over here, I'm going to find the slope of the line. We know this equation is y2 minus y1 over x2 minus x1, or change in y over change in x. And that's going to be, it doesn't matter which one you call x1 and y1. Let's do negative 5 minus a negative 3 and 3 minus 1. Okay, so this is going to be negative 5 plus 3, which is negative 2. And this is 2. Oh, this slope is going to be really nice. It's just going to be negative 1. Okay, so we found the slope. I need a point on the line. We have 2. You can pick to either use 1, negative 3 or 3, negative 5. If one person picks this point and another person picks this point, it doesn't matter. In the end, your equation will be the same. So let's go with the 1, negative 3. This says using slope-intercept form, so y equals mx plus b. If I plug in what I know that the slope is negative 1. I'm not given the y-intercept. Neither of these points is the y-intercept. So what I'm going to do is I'm going to take 1, negative 3. I'm going to put the negative 3 in for y and the 1 in for x. And what that allows me to do is now solve for the y-intercept. So this is negative 3 equals negative 1 plus b. I'm going to add the 1 over here because this simplifies to 1. I'm sorry, it simplifies to negative 1. You got to add it to the other side then to get b by itself. So this is negative 2 equals b. There's my y-intercept. Now I just plug back into slope-intercept form. I know the slope is negative 1, and then the y-intercept is negative 2. I'd actually prefer you to probably write this negative x minus 2. I wouldn't take off points for not writing it like that, but anytime there's a 1, you don't have to write it in front of the variable. Okay, so there's our equation of the line. Okay, let's see if we get the same thing doing it a different way. This way is using point-slope form. I will still need the slope. I always need to know what the slope is every time, and we actually already found that. It's going to be negative 1. All right, great. Now we're going to use our other formula. We're going to use this guy, point slope. It's called point slope because it uses slope and a point, hence the name. Okay, so let's plug in. I'll actually, just to show you that it doesn't matter, I'm going to choose the other point. The other point on the line is 3, negative 5. Let's plug in a negative 5 for y1 and a positive 3 for x1. Now I've got this kind of ugly looking equation. We like to have our final answer where y is by itself. So let's simplify some things. This becomes y plus 5. Let's distribute the negative 1. So negative 1 to the x is negative x. And negative 1 times negative 3 is positive 3. One final step, let's get y by itself. So y equals negative x minus 2. And look at that, it is the exact same equation. We just got there a different way. All right, so if the problem doesn't specify which thing to use, it's up to you. If you are more comfortable with slope-intercept, go for it. If you like point-slope better, that's fine too. I tend to use point-slope a little bit more, so that's something that you'll see me do more often, but whatever floats your boat is fine. All right, let's take a look at the bottom two examples here. I'll do the first example using slope-intercept form, and then I'll do the second example using point-slope form. Okay, so the first thing I always need to do is find the slope of the line. So m equals y2 minus y1 over x2 minus x1. And that's going to be, let's see, negative 3 minus a negative 4 over negative 3 minus a negative 10. Lots of negatives going on here. This is going to end up being negative 3 plus 4, which is 1. And this is going to be negative 3 plus 10, which is 7. Okay, so I know the slope. I'm going to plug into this form, y equals mx plus b. I know the slope is 1/7. Oops. And let's work with the second point, negative 3, negative 3. It's a little bit easier. Negative 3 goes in for y. It also happens to go in for x. So simplifying this a little bit, this ends up being negative 3/7. Trying to find that y-intercept. I'm going to add 3/7 to the other side. It's going to be a little ugly. Negative 3, I'm going to change that. I'm just going to bring that up over here. I'm going to change that to a negative 21 over 7. It's the same thing as negative 3. I'm going to add that 3 over 7. That still equals b. And that's going to get me negative 18 over 7. There is b. Let's just plug back into our equation. Our slope is 1/7. And our y-intercept is negative 18 over 7. And that is your equation. Okay. All right, the next one. We're going to use point slope form. So we still have to find the slope. You always have to find the slope. Let's make sure you can see this. So change in y. would be, let's see, -1 minus 8 over change in x, which is -2 minus a -2. Uh-oh, this is interesting. Okay, so the top is going to be -9, and the bottom is going to be -2 minus a -2. This is weird. Okay, so -2 plus 2, that gives me 0. I'm actually not allowed to divide by 0. That gives us an undefined slope. This is weird. You know what, let's just plot these points and let's see if we kind of figure out what's going on here. So -2, 8, real quick, doesn't have to be perfect. Okay, so there's a point on the line. -2, -1, there's a point on the line. If I connect these, hopefully you recognize that that makes a vertical line. And the vertical line is always going to have the equation of x equals a number. So that number is just -2. All right, so if you get that undefined slope, that's your clue that something weird is happening here. All right, and there we go.